Okay, we're going to keep going. I'll probably not say a lot in this video. You have the quadratic formula right up there. Here's your A, here's your B, here's your C. Okay, so here's the B value. So the opposite of B, B squared. Here's the A value, and that the quadratic says subtract 4A divided by 2 times A, and then the C value. And it all matches up. Whoops. Okay, and then we're just going to simplify. Inside there, let's see, 10 squared is 100. Subtract a negative, same as adding. And then 4 times 3 times 23. 276. When you add that together to 100, you got 376, which I think is a perfect square. So the square root of 376, it is not. So we have negative 10 plus and minus square root of 376 all over 6. But 376, I'm going to go ahead and divide that by 16, see what we get. No, that doesn't work. Let me try 36. Okay, let me just try 4. 4 should work. So this is 4 times 94. Yep. All right, and the square root of 4 is 2. So and then notice 2, 6, and negative 10 all have a 2 in common. So 2 divided negative 10 is negative 5. 2 divided 2 is 1, so we don't have to write it. And 6 divided 2 is 3. So those are your two options. Negative 5, subtract root 94, divide 3, and negative 5 plus root 94, divide 3. Okay, when you get down here, we need to zero out the right side first. So we're going to add 7, then rewrite the quadratic. And now you have your A, your B, and your C. All right, so opposite of negative 1 is 1. Inside here, negative 1 squared is 1. Subtract a negative is adding a positive. And then you've got 4 times 3 is 12, times 8 is 96, plus 1 is 97. And that's a simplified, so it's 1 subtract root 97, which is a little bit less than 10. So 1 subtract 10 is negative 9 over 16. So a little bit more than negative 1/2. And then 1 plus root 97, which is almost 10. So 11 over 16. And then negative 3 is where it's going to touch the y-axis. I'm going to call this negative 1. Call this 1. So close to negative 1/2. A little bit more than positive 1/2. I don't have that graph very well. But there you have it. And then halfway between is an axis of symmetry. Okay, one thing to notice, these all have a 2 in common. I can divide both sides by 2, or another way to do it is to keep the scale factor. We're going to factor out a 2. So 2 divided 2 leaves x squared. 10x divided 2 leaves positive 5x. 2 divided 2 leaves 1. All right. And here we're using the ABC. Right, and then you just simplify that. 5 squared is 25. Subtract 4, because 4 times 1 is 4, times 1 is 4. So that becomes 21, which can't simplify further. So x is equal to negative 5. Subtract root 21 all over 2. And negative 5 plus root 21 all divided by 2. And we're going to touch there at negative 1. Okay, now it just tells us to factor. Well, 9 could be 9n times n, or 3n, 3n, just like that. So we have to do factors of 50, 25 and 2, 10 and 5, 50 and 1. So let's see, they have to add up to 55n. Factors of 50. Factors of 50 will go here, here. Factors of the 9n squared go here and here, or here and here. And let's see what we can do. They have to add up to 55n. So if we choose these factors right here, so if I put 5 there and 10 there, yep, that should be good. Okay, and what I should add, remember how we know that is these two get multiplied. Well, that's 15n. So the two outside ones multiply. The two inside ones multiply. Oh, that does not add up to 15n. So that is not it. Oh, that is not good. So let's do this. I'm going to pause this again. All right. So these are going to be the factors right there. And we're going to go here. So if we put the 5 there, the two outside ones, sorry about that, 45 in, 5 times 10 is 50. And then the two inside ones multiply, n times 10, which is 10n, and then you add the columns and you get 55n. All right, let's go on to solve by factoring. Solving means you do all of it. Y-intercepts, two roots, axis of symmetry. Here's a special situation. Take a look. Here we have a perfect square. Here we have a perfect square. And perfect square, whoops, perfect square trinomials will factor to a binomial squared. And how you do that is you take the square root of the first and third terms. So the square root of n squared is n, the square root of 9 is 3, and then you take the operator, the first operator. So it looks just like that. That's how you would solve that, except for that becomes squared. And this would be one when you go to graph it, right there, positive 3, way up there at 9. So whenever you have this multiplicity of 2, meaning something squared, the graph is going to sit right on top of the x-axis. So factors of 2 that add up to 3. Well, 2 only has 2 times 1, and that does indeed add up to 3. Oh, this actually said solve. So then when you go to solve it, you just take the opposite of what's inside. So the opposite of 2 is negative 2. The opposite of 1 is negative 1. Then our y-intercept is 0, 2. Our axis is sim. And I'm writing that sloppily. All right. Where? And that's just halfway between the two roots. That would be negative 1.5. So we have enough information. We know where it's touching the y-axis at positive 2. We know what the two roots are. -2, -1. It's going to look something about like that. All right, I think that should be good for today. But you need to finish these other. Time's probably not finished in class. Finish these others as we in class. And any that we missed, looks like we didn't do number 10. So do number 10, 15, 16. Yep, that's it.